Hello everyone, greetings and welcome to our webinar. It brings me a great pleasure to have you all in attendance today as we explore an insightful program. Our speaker for this event is one of our well-experienced engineer Niaz, who has been an integral part of KubeDB team for an extended period of time. As we commence, I would like to highlight the importance of your involvement and contribution to this webinar. If you have any questions or queries, please don't hesitate to raise them in the Zoom chat and we'll answer them during the QA segment. Without any further delay, let's proceed to the program. I would like to hand over to our speaker, Niaz, who will provide valuable insights regarding the topic. Over to you, Niaz.
Okay. Um, okay. I hope my screen is visible.
Yeah, it's visible.
Okay. Hello, everyone. This is Niaz Murshid, software engineer at Xcode, and I am one of the members of KubeDB team. So our today's webinar is about provisioning and managing ProxySQL cluster for different backends like MySQL, MariaDB, and Percona XtraDB Galera cluster. So let's start. So first, let's see the table of contents that we'll discuss today. First, we'll talk about what is ProxySQL and why we use KubeDB ProxySQL and how ProxySQL load balance and how the KubeDB ProxySQL actually does the load balancing work, and we'll see a live demo on using KubeDB ProxySQL. So, and in the end, we'll have a Q&A session. So if you have any questions, then you can ask. Okay, so now let's say you have a MySQL cluster, a MySQL group replications, and maybe like like a MariaDB Galera cluster or Percona XtraDB Galera cluster. So, and if client connects to the MySQL nodes randomly and different executes different redirect queries, then it is tough to actually monitor and route traffic to specific MySQL nodes based on like query rules. And so ProxySQL helps with this with different features like you can set query rules. Different types of query, when it matches with a regular expression, it goes to a specific set of MySQL pods or nodes, and it also has query caching support, where like you can uh, you can enable caching so that same queries result can be returned without actually connecting to the database ports. And yeah, you can also enable you and ProxySQL also does the load balancing work for you. So it's a system where you can set a query rules, so which kind of query should go to which MySQL server. And if there is like repeated queries, you can send the result from the cache. So yeah, so ProxySQL has some advanced connection management and connection pooling features, which optimizes the performance and high availability of the databases. So it's ProxySQL is an open source, high performance and high availability database protocol, where proxy uh, for MySQL and MySQL forks like MariaDB, Percona XtraDB. So Okay. It has also clustering support. Like if the connections can be ProxySQL actually does the proxies the queries without directly executing in the database pods. So it has also clustering support, which so if you need a like high availability proxy, so if any of the ProxySQL pod fails, then your setup is not high available. So you have to you can enable ProxySQL clustering. So where ProxySQL node distributes the load among themselves, and it enhances the performance significantly. So some of the use cases of ProxySQL is like the connection multiplexing. So there are different number of connections which will go to the ProxySQL, and the ProxySQL will a specific a fixed number of connections to the database end. So so front-end connections are multiplexed into like fewer backend sessions. So it will drastically reducing the database connection overhead and improving the throughput. So and for the query caching, it is also very powerful features. So in-memory caching of query results, which will actually reduce the repeated database hits and accelerates the response time for frequently executed systems statements. So and it has also query rewriting support, and for the high availability and failover, it has a support for read write splitting and load balancing feature. So you can set query rules so that read queries will go to a specific set of nodes, and the write queries will also go to another like specific set of nodes. So you can distribute the read write queries also. And if you set like uh, you can for the read queries they all also will be load balanced, so depending on the number of available nodes. So and it has automatic failover detection, so continuous health checks shun unhealthy backend nodes and read out traffic to healthy nodes, ensuring the uninterrupted service. So okay, and yeah, you can set up a zero downtime configuration using ProxySQL. So and for um, and for query control and security, it has advanced query rules and firewall setups. You can like regular expression based rules. You can set regular expression based rules that let you route and reject or throttle queries, while the built-in firewall blocks malicious or unwanted SQL patterns. So it has authentication and access control mechanism advanced, and for the observability and management, it has real-time monitoring features also. So it will monitor the backend nodes, and in case of any of them fails, it will not uh, execute queries to that node. Yeah. So failover management is also available, and you have the flexibility to set up ProxySQL clusters and synchronization. So multiple instances can synchronize configuration for HS setups. So yeah, maybe front end by a cloud load balancer. So okay, now why use ProxySQL using KubeDB? Like so if you want to set up a ProxySQL cluster by your own, then you have to configure so many stuff. Like you have to create a monitor user in the MySQL or MariaDB backend side, so that the backend spots can be monitored by ProxySQL. And for that purpose, you have to inject additional um, uh, like sys queries, and also you have to set up like ProxySQL servers table. You have to add the MySQL nodes to the ProxySQL server pool. So yeah, there are so many stuff you have to do manually, but with KubeDB you can just apply a YAML, and maybe from the UI one click is enough to create and set up a ProxySQL cluster. So you have to just mention the MySQL reference uh, in the ProxySQL YAML. So yeah, so what KubeDB offers for ProxySQL? So it simplifies provisioning ProxySQL clusters on Kubernetes. And KubeDB has like custom configuration support, authentication, and customizable health checker support, health checks. For it has also like support for TLS security connections for front end and backend. So from the client to ProxySQL, you can enable TLS security connections. Also, from ProxySQL to um, MySQL, you can also enable or disable the TLS security connections. So yeah, we have multiple backend support, um, like MySQL group replication cluster, MariaDB Galera cluster, or Percona XtraDB Galera cluster. So, and for different operations request, like we call it ops request. So you can do automated like version update, horizontal vertical scaling, reconfiguration, and reconfiguration of TLS using like the same way, applying a simple YAML, mentioning the type of operations, and the ProxySQL name. So yeah, and for the reconfiguration, yeah, for the secret or the new configurations, uh, and it has also auto scaling support for compute resources, like CPU. And KubeDB has also monitoring support for ProxySQL using Prometheus and Grafana. And we have support for production ready versions like 2.7.3, 6.3. Yeah. So now let's see a live demo of how you can use KubeDB to in using ProxySQL. So how you can actually use ProxySQL using KubeDB? So to install KubeDB, you can you have to run a help command like this to and enabling the ProxySQL feature case to true, and and with your relevant backend databases. So this is a sample YAML of ProxySQL. So like it is working for the backend MySQL server, and it is a clustering setup. So it has replicas to 3, and its version is like 2.7.3. Yes. So this simple YAML is enough to create a ProxySQL cluster using KubeDB. So now let's see the live demo. Okay, so before so you need to have a Kubernetes cluster and you have to install KubeDB. So I have installed KubeDB. So like let's see the KubeDB version that is installed. So I have installed the latest KubeDB version 25 43 430. So these are the KubeDB pods that is running in my cluster. So and I'm watching MySQL, MariaDB, Percona XtraDB, and ProxySQL, and different resources of those. So I have so let's see the YAMLs first. So I have created the backends earlier. So this is the MySQL YAML that I have created. So this is the name and namespace of MySQL resource, and it has version 8.0.36, and it is like a group replication cluster of 3 nodes. Yeah, and some storage configurations. So I have created the MySQL server earlier, and I have also created the MariaDB and one Percona XtraDB also. So let's see the YAMLs of those. So for the MariaDB Galera cluster, I have applied this YAML. So I'm using this version of 3 replicas. So the Galera clustering mode is the default mode of MariaDB for KubeDB here. And yeah, and for Percona XtraDB, it's also the same. I created a Galera cluster of 3 nodes of the version 8.0.40. So yeah. So now let's exec into one of the ProxySQL. Okay, now let's create a ProxySQL for our backend like MySQL. So let's create the MySQL proxy using version 2.7.3. So it is it will be a cluster of 3 nodes. Yeah, so let's apply this first. Okay, so ProxySQL is created and it is in the provisioning state. Okay, we can see that the ProxySQL is ready now. So let's exec into one of the ProxySQL pod. Okay, so let's connect to it. Let's connect to the admin panel. Yeah. So now let's see the uh, group replication host groups configurations. So we have uh, for default, so we have a writer host group is 2, and backup writer host group is 4, reader host group is 3, and yeah. So this is the default host groups configuration for MySQL in KubeDB ProxySQL. So let's see the MySQL servers uh, of like ProxySQL. Yeah. So we have so you can see that the MySQL ports are actually um, inserted here. So MySQL nodes in host group 2, which is the writer host group, the primary node is actually inserted here. If we connect to the MySQL, okay, let's connect into the MySQL node. Yeah, so we can see that group replication members of the MySQL cluster and port 0 is the primary port. So this is actually dynamically inserted in the writer host group by KubeDB operator, and primary port and the other secondaries all are all can take read queries. So we have inserted in the reader host group for all the ports. So this is the updated configuration. Previously we were like inserting the service endpoints. So So we have moved to service DNS to pod DNS in our latest release of KubeDB. So we have improved ProxySQL like integration with MySQL and other like MariaDB and Percona XtraDB um, backends by like switching from Kubernetes service DNS to individual pod DNS. So which will eventually give us some benefits like direct routing to pods instead of the service, and it will also enable the fine-grained failover, so traffic can be redirected on per pod basis in case of failures, and also it will improve like query routing, so based on host group rules, replication matrix or pod health. So it will route the query to the appropriate healthy nodes. And yeah, we will observe like we can observe now individual pod label. So each pods has a status like online or shunned or offline. So it gives us the higher resilience, so reducing the reliance on service level load balancing. So basically, now ProxySQL does the load balancing, but in our previous setups, we were inserting the service endpoints here. So actually, the service Kubernetes service was doing the load balancing work. So yeah, so we have improved the configuration. Um, okay, now. So let's see the MySQL users that is available in the ProxySQL. So we can see that only the root user is available. So let's create another user here in MySQL. So in the MySQL side, okay, select user from MySQL.user. Okay, so we can see that in the MySQL, a user named ProxySQL is created, which is created for the monitoring purpose and by the ProxySQL operator. So this is the monitoring user of ProxySQL. So and there are some other users, but we have already inserted the no, non-system user. So yeah, so root user is available in MySQL users table of ProxySQL. So let's see the runtime configuration. Yeah, so let's insert another uh, user in MySQL. So let's create like test user and grant all privileges for testing purpose, and yeah, flush the privilege. So let's see. In our setup, we have enabled the sync users to true, which means that in the MySQL server side, if any users is updated, like their new users are added or users deleted or their passwords are updated, then the ProxySQL automatically will synchronize those users. So let's see. Yeah, so we have our new users in the ProxySQL. So now let's create a database maybe. Yeah, let's create a database in the MySQL side. Okay. So we have not inserted any data into it. Test table. Yeah, so no data. Now we will connect using ProxySQL to insert some data into the MySQL side. So for that purpose, we will access from a different port. Like I have created a Ubuntu port for this. Yeah. So let's install the MySQL client. Okay. So we can now connect using the ProxySQL service. So ProxySQL service will eventually connect to one of the uh, ProxySQL pod. So we have connected to MySQL using the new test user that we have created. So so connection is established successfully. Now let's access the databases. Okay. So select maybe host name. Yeah. So we can see that we have connected to the backend MySQL Server 0 port. So yes, now let's insert some data into it, into the table. So use test. So we can see that we have executed the queries using ProxySQL. So connections are working fine. Yeah, so from the ProxySQL side, so we have connected to, okay. So we have seen we have seen for the MySQL group replication cluster. We can now we will see how we can use ProxySQL for MariaDB Galera cluster. So let's create MariaDB proxy now. Let's connect to MariaDB proxy. Okay, so MariaDB proxy is ready now. Yeah, so we have connected to the, let's connect to the MariaDB, one of the MariaDB proxy ProxySQL pod. Yeah, we have connected to the admin panel. Let's see how what is the configuration of MySQL Galera host groups. So yeah, we can see that these are the default configuration. So now let's see the MySQL servers. Yeah, so in the writer host group too, since the Galera cluster actually uh, since the Galera cluster supports read write for all nodes, so basically all nodes are primary in MariaDB Galera clustering setup. So all the three nodes are inserted in the writer host group, but the max writer is set to 1. So basically from in the ProxySQL side, only one pod will be online. You can obviously uh, customize the settings, but for default we have uh, kept one primary pod in the writer host group, so that like for write queries, the conflicts are minimum. So you can obviously reset this configuration. So yeah, so we can see that for because of max writers is set to 1 in MySQL Galera host group settings. So only one pod is online, and remaining two pods are shunned. So, and for the reader host group, all the three nodes is available and online. Now let's try to access MariaDB using the ProxySQL cluster that we have created. Okay, and let's see the users that are available. So for health checking purpose, a new user was created, and in the MySQL, which is also since here, since we have also enabled sync users for this ProxySQL cluster also. So all the users that are available in the MariaDB side, the non-system users will be synchronized to the ProxySQL automatically. So yeah, now let's in the similar way, let's create a new user in MySQL, in the MariaDB node. Okay, let's create a test user, and yeah, again, let's create a test database in the MariaDB side and create a like test tables. So there is no tables here. Let's create one. Yeah, now like grants the test user all the permissions. Yeah, so let's see in the MySQL users table. Yeah, so we have our new test users available. So now let's connect using the ProxySQL service again. So so let's see, we can connect to the MariaDB Galera cluster ports using the ProxySQL. So yeah, we can see that we have successfully connected to the MariaDB. Let's see the host name. Select. Yeah. So since the service actually forwards the traffic to one of the backend MariaDB port, so sorry, yeah. So service redirects service forwards the traffic to one of the MariaDB ProxySQL pod, and from the ProxySQL, uh, the connection is established from to the one of the MariaDB backend pod. So we have connected to the Galera cluster 2, MariaDB Galera 2 pod. So we can see that we have, yeah. So these are the Galera ports, MariaDB Galera ports that are available. So we have connected to the Galera 2 ports. Okay, now let's try to access the database. Okay, so we can access the databases. Let's insert some queries. Yeah, inserting some demo data. yeah, we can see that we can execute. We have successfully connected using the ProxySQL. We can also execute queries, redirect queries. So that's it for the Percona XtraDB Galera cluster. The process is same. We can use KubeDB to actually simplify provisioning of ProxySQL in Kubernetes, and we can use the available KubeDB features for ProxySQL. Yeah, so let's go back to the slide. So that's it from my side. If anyone has any queries, you can ask now.
So if you have any questions, you can ask them in the Zoom chat, or maybe you can raise your voice and ask them in the meeting. We are open to questions regarding KubeDB or maybe the project that was discussed by Nyaj. So I guess there is no question at this point. Thank you all for your participation, and we look forward to our presence in our future sessions. Visit our website appscode.com/webinar to check the schedule and register for upcoming events. Wishing you all a very great day. Bye bye.